Hi, Dr. Anthony Revis. Watch me do it. I'm going to do a Hess's law where you have to rearrange the equations. Those tend to be somewhat challenging. So watch me do this one. Here we go. Here it is. What is the enthalpy of reaction of the following reaction? So we have this reaction and we have these equations. And when you see that, you're going to rearrange these equations to match this final output that looks like this. Okay? And that's the goal. And you want to follow rules of math when you do that. That's it. So let's do it. So we want to rearrange the equation 1, equation 2, and equation 3. These are all from standard tables until it looks like our final reaction shown above. All right. So when I look at this then, and I have these values, let's see if I have everything here in a good order. Yes, I do. Okay, so the first one I'm going to do, first thing I'm going to do is I'm going to go ahead and try to match out things that I tend to think are easier, if you will, to match out. And what I see is I'm going to start with equation 2 because I can see my reactant. So I just start here. I just pick first thing up. I see this and I see this equation 2, so I'm going to write it. And since it is already on the side of the equation that I need it to be on, occasion for speed, I'll leave the states off. That happens just for speed. That's the only reason. And so I'm going to rewrite this equation because I see this in there. And when I rewrite it, it's going to stay the same, right? So since it's going to stay the same, I'm going to go ahead and assign to it a minus 65 kilojoules. So that's what it is. And then I'm going to look for my next material here. And I say I have chlorine on the left side here. So since I have chlorine on the left, I'm going to go ahead and pick equation number 2. So this is equation number 2 rewritten. I'm going to pick number 1 because I see chlorine on the left side right here and right here. So I know that equation I'm not going to have to rearrange. I can rewrite it as H2 gas plus Cl2, because I just see it, it's just looking right there at me, equals 2HCl. I'm not going to worry about the stuff that adds to it. I can work all that out later. Okay, so don't worry about what's too much in there. Someone's going to say it's too much in there. I know it is. So we're good there. So we've taken care already of 2 things. We've taken care of the C2H4 and the Cl2. And so that only leaves it with equation number 3 left to work with, right? So now, if I look at equation number 3, I notice that this is on this side. Therefore, I have to flip that equation. And if I flip that equation, I have to also flip the sign. That's just how life works for it. So if I flip that equation, I'm going to now have C2H5 Cl on this side plus nothing plus. So I'm going to have an arrow going to the other side. It's going to be C, ugly arrow, but it's an arrow nonetheless. 3Cl gas plus H2 gas. And I flipped it, so it's going to be plus 140 kilojoules. And now I have those arranged properly. Okay, this is an H2, by the way, and that's gas. And so now what I'm going to do is look to see what's common that I can cancel out. Oh, I say cancel out one of these HCl's off that. You crisscross cancel, okay? I also see, oh, I have hydrogen here that can cancel with hydrogen there. And when I cancel those out, my result, I draw a line and draw what's left is C2H4 plus Cl2. Oh, you know what else I can cancel out? This. And when I do all of that canceling, see what I'm left with, that. And over here, I'm left with C2H3Cl gas plus HCl. I believe that was gas. It's important to note the states, but occasionally you get a little sloppy and leave them out. So then now I know I can just add all this up, add these values. If I sum these, I get a negative 110 kilojoules. And that's just how I work it. So the key to doing this is to rearrange the equations until we match and cancel out. Don't make a big deal of it. Just cancel out, use rules of common math, and it works out pretty good for you. Okay, so that's how we rearrange these equations to do a Hess's law.